Hi guys, Fox here. Today I'm gonna be replacing a laser tube on my big ass laser cutter, and that's the laser tube, which is also big ass. So how I will look with the bazooka. Um, yeah, that's the new laser tube, and yeah, that's the boom boom end, and that's the boom boom cable, which delivers, as far as I remember, roughly 24,000 volts. Uh, so you don't really want to touch it. And I know that because once I did touch it, and I'm still alive, I'm tough, you know. I will tell you something more about the laser. That's the full-size laser cutter, and it's 3 meter long by 2.4 meter wide, I think, something like that, or 220 to 40, something like this. And the space in the bed, it's 1.5 meters, and the usable space, it's only 1.3 meters. It's capable of cutting full-size sheets, which is 2.4 by 1.2 meter. Why I got such a big laser? Because of the offcuts. I had previously 60 by 90 centimeter laser, and the annoying thing was that I had to cut the sheets into something smaller. That was, lots of offcuts, lots of waste. I had also a 4 laser cutter. It was even more cutting to fit it there, and the amount of waste was tremendous. So I decided to, yeah, I don't want to deal with that thing anymore, and I got the full size laser cutter. So I put the acrylic on it, full sheet of acrylic, and I cut from the top to the bottom, and I don't have any waste. I mean, I have waste, but not that much. And then I don't have to beg people to cut me something on half or things like that. It was serving well. I got it 4 or 5 years ago, and I did thousands and thousands of hours on it. Laser tube has to be replaced, and the laser tube's supposed to last for 5,000 hours, I think. There are some for 10,000 perhaps, but I don't really care. It's not that expensive. That the laser tube was $300 something, I think, for 100 watt. So it's not like the end of the world. Everyone is curious how much laser like this costs. So the prices are random, depends where you live, but usually it's between 30 and 60 grand for laser like that. I didn't want to pay that much because I think it's not really worth it. The laser is pretty much like a construction of the hammer. There is not much into it. So you have your laser, and then you have your controller. You have steppers, so kind of like it's more like a 3D printer, but upscaled. And laser goes into here, and it has what, 1 to 3 meters. Obviously steppers and the power supplies for the steppers, which I'm gonna show you in a sec. So I've been considering building a laser myself, but as you can see, there is plenty of metal around it, and frame and the rails and belts and stuff. And if I would like to build it myself, it would take me months. The amount of money I would spend on the material, it would be more than if I would import that from China, and all the conversion stuff and so on, and transport, customs, blah 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 blah. I think I paid around 12 grand for that thing, so it's much cheaper than the lowest 30 or 60, right? I don't have to deal with making a frame, finding parts, importing parts, paying more, shipping and stuff like that, and someone already built that for me. When it arrived, it didn't really work. There is that thing over here. That's the industrial chiller, and that thing worked when I turned it on, but when I turned it on again, it didn't want it to turn on. So I had to fix it. It wasn't bad, it just few connectors. The carriage on that axis was damaged on the shipping, I think, so it didn't really want it to move. It was kind of locked. So I had to sort this thing out first. Then when I turned on the laser, it didn't want it to cut. So I had to, figure it out, what went wrong. They power it with the computer cable. That the socket burned down like in flames after, I don't know, 4 hours of cutting. Since I got it, so it wasn't continuous 4 hours, but after 4 hours of cutting here and there, that went in flames. Then a stepper driver got burnt because they connect the cables wrong. So I had to rewire, like, wasn't even rewiring, reconnecting every single cable. Once I've done all of this stuff, the laser was going for years. Maybe one thing, how heavy it is. It weighs around 750 kilograms. It's on wheels, so you can push it by yourself. It's like pushing a car. Not the easiest, you can do it. So I think I'm gonna shut up and start showing you around. It has all sorts of doors in here, all around it. So I'm using it as a storage for the stuff which I'm not using very often, because that's a waste of space, and using those compartments, it's a really good utilization of space. Here is the compartment with all the electronic bits and some of my storage. So what is here? You can control it through the Ethernet, or connect them as you want. So this one is for the pump and the laser, then the lower one air exhaust, and one below it's for the light. So here you have a controller which goes to the screen on the top. Stepper drivers. This is the breakup board, which you have a power from somewhere coming in and splits into all other powers, and it's connected up, down, up, down, up, down, up, down, up, down. Here you have power supply, and I guess that one is for steppers, and that one is for the controller. Over here you have the laser power supply, and that one is 100 watt. Okay, so the way how you turn on the laser is you just undo this, and it turns, and they're gonna turn off the fan, and perhaps they're gonna move the laser tube into a safer location. This is the laser bed, and it has those fins which you can remove and clean the mess which you've made by the offcuts. And I usually use that thing as the temporal recycling bin, or just the trash. And how it works, because it doesn't have a cover, so it has the exhaust fans in here. So when you turn the fan, it sucks the air from here and over there, I guess in here, where is my knife? On the both sides. So here and here, and there on that side, and on the other side over here. Since I'm changing the laser tube, I thought I might also, pull those fans and clean the mess inside. I usually clean it once a year, or maybe once 2 years. I think the last time I cleaned it, it looks like maybe 2 years. So I'm not always throwing so much shit in it. It's just recently I knew the cleaning time is coming, so I was dumping whatever was easy to throw, basically. And I will use my pad to move the laser closer. So that's the end of the travel, and now I'm gonna lift it up. Okay, and I'm gonna take the camera from the other end so you can see how the laser looks. That's the boom boom end of the laser, and it shoots to the mirror over there. I'm not sure if you can see it. I'll show you later. It bounces like this and goes back around. Okay, so I guess now I have to get some tools and remove the clamps. So yeah, the laser, it's only placed by those two clamps. Okay, loose and loose. I'm gonna keep those spacers. It's not the prettiest clamp I've seen, but it does the job, and it did for the last couple of years. Okay, so here I have a connector which I will have to disconnect. I'm gonna put the spacer, and I hope I won't need to do too many adjustments. Okie dokie. So it's in and it's in. Okay. So now I can plug the water. Okay, so the water in, and then the other water. Okay. Okay, it's in. Okay, a new zip tie. And you don't really want to use those metal clamps on the glass, because you might tighten too much. So the zip ties work pretty well. Okay. Perfect. Okie dokie. Whoopsie. It's very sticky. I think I like the placement how it is. Now I'm gonna put the clamp back. Bolt it in. So when you're clamping back the laser, you don't want that to be too tight, but you don't want that laser to be sloppy either, So have to find some middle ground, because if the laser will be flopping loose, then it might cut with a kind of chatter like in CNC. Might miss the mirror and you're gonna hit something by accident. So yeah, it's better to have it securely placed and without the way for that thing to move, but you cannot over tighten it because you're gonna crush it. I think it's solid enough. Okay, So now have to get the ground and wire it. Tape. Perfect. I think I can remove the old laser now, put it to the box, and have it as a spare laser now. And now the boom boom end. I have to push this through. Yeah, that cable is pretty thick. Insulation mostly. Okay, so I can undo the water. Good, nothing is flowing. And now I will connect those two. It's good. Now to get that insulator, you know, it's pretty thick because it's you know, the spark can fly really far from 20,000 volts. Tape it. Some extra protection, and it's used, you know, just to prevent that thing from separating and exposing that wire. Perfect. So to block the laser, because it's not set yet, I'm gonna get that steel plate and I'm gonna put it here because, you know, I want to do the test and see if it's working, and I hope it won't reflect too much light, but just in case I'm gonna rotate it into somewhere where it won't be too dangerous for me. And okay, so the water is pumping through now. No leaks. I have two bubbles over here. Okay, that one disappeared and now this one disappeared. So I think I'm gonna leave it in this orientation. That should be good enough. No bubbles whatsoever. So I'm gonna pulse the laser with that piece of plastic so I don't touch anything metal, and the laser. Wow. Okay, it works. Let's see it again. There is no spark going. Maybe I'm gonna show you that mirror over there. Okay, so mirror is here. So that hole, it's where the laser goes. It bounces through that 45-degree mirror over there, and it travels in here, and it exits in here, because here is another 45-degree mirror, which is like this. So they like that, and I'm pretty sure the laser is quite well aligned because it's not like different size or different angle or anything. So I don't think I will have to adjust the mirrors, like maybe the last one, like last two, and that should do it. But just in case, I'm gonna put my steel plate on front of it, and then I'm gonna use the tape to see where at the hole the laser is coming from, if it's coming at all, and I'm gonna press fire. Okay, so the laser hole, so it came out. It's good. I'm gonna move it as close as I can. Okay, so I have a packing tape on front in here, and I'm gonna do short impulse. Okay, is it aligned? Yeah, I think it's pretty well aligned. It looks like it's a bit high. So now I can do another test. Okay, so it's straight on, and I'm gonna see if it's gonna hit the edge of the circle or not. Okay, it looks, yeah, I still think it's a bit high, but it looks like it's in, so I'm gonna move it further away, not too far though. So I moved it that far. Okay, and now I'm gonna put it again on front and see if it's gonna be high again. It's still in. Kinda barely in. So now I know it's the same height, more or less, and I think if I'm gonna move it to the very end, it will be still the same thing. And I think it's gonna fire again just under the edge. Yeah, and slightly on the left. Okay, so it means that the last mirror, it's fine, as just the first mirror of the laser has to be slightly tweaked. Yeah, so what I have to do, I have to point it a bit lower. I have to point that mirror a bit lower, so it hits this mirror a bit lower, and it sends, you know, the beam not high, but, you know, lower and parallel to that axis. And yeah, well, let's see. Okay, and I wish to show you how it looks, but it looks pretty much exactly same as this thing in here. So it has a couple of knobs, and it looks exactly like that. The laser comes here, bounces. You adjust which way you want to position the mirror, so you have 3 screws. Okay, I touched it a bit, and just to don't confuse you too much, can I use the new piece? Okay, so it looks centered, but it doesn't look like it's any lower. And I put the new tape. Okay, moved it back. Yeah, that's better, but now it's on the left. Okay, I moved something. Okay, it's getting there. Okay, I moved it a bit. I think I have to move it slightly more than that. Okay, and now? Didn't notice anything. So I'm just gonna get the new place. Boom. Almost the center. I think now it is the center. Okay, now I will be lining the laser which comes in here, bounces from the back mirror and goes down through the lens in here. Before I was like undoing the tube and taking off the glass, and I was shooting to have the hole in the center of the tube. I found it to be not the greatest because you have the lens in here and it depends if how the lens is made, if it's placed straight or blah 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 blah. It might output slightly to the left or to the right. So now I'm just like taking off the compressed air and I'm just sticking it barely. It builds up the pressure, but it doesn't blow the tape. And if I press it underneath, I will have a imprint where the nozzle is. So now when I'm gonna do this and I will shoot, it should tell me where is the hole. Is it center or it's not? Now we're gonna do a test on a 3mm thick acrylic. So I'm gonna be cutting 35 millimeters per second and 98% of the power. So let's go. And there is the circle. Just have to push it in. On the old laser I was cutting that circle in I think 15 millimeters per minute because it was old and it was losing power, and now I can do it at 35 millimeters per minute, which is a huge time saver, especially when it comes to thicker stuff. So as you can see, I cleaned it up and it looks much better now, I believe. I guess that was quite a long video about the laser, but I tried to put as much as I can, and I wasn't cutting much because you might find some parts interesting to see more in depth. I'm sorry I didn't show anything inside, how it looks, the mechanicals, but there is no space just to put the camera from the back. Yeah, so I think that would be all for this video, and I would like to recommend my next video, because in the next video I will be unboxing and testing my new laser, which is fiber marking laser, and I'm really thrilled to put my hands on it. So stay tuned and see you next time.